Saving the ocean starts with you. Environmental conservation training. Ballast water management plan. Introduction. On board ship, ballast water is essential to control trim, list, draft, stability, or stresses of the vessel. But this ballast water may contain some aquatic organisms or pathogens which, if introduced into the sea including estuaries, or into the fresh water, it may create hazards to the environment, human health, property, or resources, and also impair biological diversity or interfere with other legitimate uses of such areas. Ballast water management plan is written in accordance with the requirements of Regulation B1 of the International Convention for the Control and Management of Vessels' Ballast Water and Sediments, 2004, the Convention, and the associated guidelines. This plan may be inspected on request by an authorized authority. Purpose. The purpose of the Ballast Water Management Plan is to meet the requirements for the control and management of vessels' ballast water and sediments in accordance with the guidelines for ballast water management and the development of ballast water management plans, G4, Resolution MEPC.127, 53. It provides standard operational guidance for the planning and management of vessels' ballast water and sediments and describes safe procedures to be followed. The selection of appropriate methods of ballast water management should take into account the need to ensure that ballast water management practices used to comply with the Convention do not cause greater harm to the environment, human health, property, or resources of any states and the safety of vessels than they prevent. Plan has to be approved by the Classification Society and no alteration or revision shall be made to any part of it without the prior approval of class. Purpose. The Ballast Water Management Plan aims to assist governments, appropriate authorities, vessels' masters, operators, owners, port authorities as well as other interested parties, in preventing, minimizing and ultimately eliminating the risk of introducing harmful aquatic organisms and pathogens from vessels' ballast water and associated sediments while protecting vessels' safety. Good record keeping is critical to the success of a sound ballast water management program. The appointed ballast water management officer, normally chief officer, is responsible for ensuring the maintenance of appropriate records and that the ballast water management and treatment procedures are followed and recorded. It is the owner's/manager's or master's responsibility to regularly review the plan and ensure that the information contained therein is accurate and updated. Vessel particular. Description of the ballast system. Ballast water is essential to control trim, list, draft, stability or stresses of the vessel. The vessel's ballast system consists of the following. Overview of BWM methods applied. Ballast tanks pump data. Ballast water management operation. Ballast water management system, BWMS, means any system which processes ballast water such that it meets or exceeds the ballast water performance standard in Regulation D2. The BWMS includes ballast water treatment equipment, all associated control equipment, monitoring equipment, and sampling facilities. BWMS means equipment which mechanically, physically, chemically, or biologically processes, either singularly or in combination, to remove, render harmless, or avoid the uptake or discharge of harmful aquatic organisms and pathogens within ballast water and sediments. Ballast water treatment equipment may operate at the uptake or discharge of ballast water, during the voyage, or at a combination of these events. Ballast water exchange can also be used for the vessel, but only to meet the standard described in Regulation D1. as per the applicable method, i.e. sequential method / flow-through method or dilution method. BWMS means equipment which mechanically, physically, chemically, or biologically processes, either singularly or in combination, to remove, render harmless, or avoid the uptake or discharge of harmful aquatic organisms and pathogens within ballast water and sediments. Ballast water treatment equipment may operate at the uptake or discharge of ballast water, during the voyage, or at a combination of these events. During normal conditions, the treatment system is to be used for ballast water operations. However, it is possible to bypass the plant and then ballast exchange can be conducted. It is the responsibility of the ballast water management officer to decide which method is to be used, e.g. in port states where discharge of treated ballast water is not a requirement. It is the master's responsibility to control the safety of the vessel at all times. This includes evaluation of stability and longitudinal strength throughout the sequential exchange sequence. The sequence should be followed for acceptable sequence for specific loading condition. It must be ensured that the ballast water treatment system installed is approved in accordance with Regulation D3 of the Convention. All systems, type, approved by any IACS class society and physically inspected by class surveyor after installation should fulfill this requirement. The system should only be operated in accordance with the system design criteria and manufacturer's operational and maintenance instructions. When the system encounters malfunctions or failure, these are to be recorded in the ballast water record book. Ballast water exchange. There are three methods of ballast water exchange which have been evaluated and accepted by IMO. The three methods are the sequential method, the flow-through method and the dilution method. The flow-through method and the dilution method are considered as pump-through methods. Regulation B4 of the Convention requires that vessels shall conduct ballast water exchange at least 200 nautical miles from the nearest land and in water at least 200 meters in depth. If this is not possible, at least 50 nautical miles from the nearest land and in water at least 200 meters in depth, or in areas designated by the port state. All local and / or national regulations should be taken into consideration as they may specify other depths and distances from land. A vessel shall not be required to deviate from its intended voyage or delay the voyage in order to comply with any particular requirement as stated above. The voyage should be planned taking into account when ballast water exchange in accordance with the above criteria can be carried out. Because of the possibility that partially exchange may encourage regrowth of organisms, ballast water exchange should only be commenced in any tank if there is sufficient time to complete the exchange to comply with the standard in Regulation D1 and the vessel can comply with the distance from land and minimum water depth criteria in Regulation B4. As many complete tanks should be exchanged to the standard in Regulation D1 as the time allows. If for any tank the standard in Regulation D1 cannot be fully met, the exchange should not be commenced for that tank. In addition, if the master reasonably decides that an exchange would threaten the safety or stability of the vessel, its crew, or passengers because of adverse weather, vessel design or stress, equipment failure, or any other extraordinary condition, he is not required to comply with above requirements. For a suitable pre-planning, not only safety requirements have to be considered and observed, but it is also essential to know which ballast water will be discharged in the port of arrival depending on the scheduled next loading condition. Ballast water which remains on board during the voyage need not be exchanged. This will not only reduce time and cost but will also minimize risk. When a vessel is required to conduct ballast water exchange and does not do so in accordance with these requirements, the reasons shall be entered in the ballast water record book. Sequential method. The sequential method is a process by which a ballast tank intended for the carriage of ballast water is first emptied and then refilled with replacement ballast water to achieve at least a 95% volumetric exchange. All of the ballast water in each tank should be discharged until suction of the pumps is lost, and stripping pumps or educators should be used if possible, to avoid a situation where organisms are left in the bottom of the tank. The tank is then refilled with new water rich in oxygen, which might allow the re-emergence of new organisms. A detailed step-by-step operational description of the ballast exchange sequence used should be consulted prior, during and after the exchange, in addition to the safety considerations addressed below. At the same time, ballast water management officer should take account of vessel's position in relation to the land, navigational hazards, vessel traffic in the vicinity, current and forecast weather, machinery performance and degree of crew fatigue, before deciding to proceed to the next pair of steps. If any factors are considered unfavorable, the ballast exchange should be suspended or halted. When planning a complete ballast water exchange sequence, the following can be used as guidance. The sequence is to be divided into steps. Each step represents emptying or filling one tank or pair of tanks and is to be calculated as any other loading condition on the loading computer. For each step, the maximum free surface moment for ballast tanks being exchanged must be considered in addition to partly filled tanks. Amount of consumables can be assumed constant unless significant change during the sequence. If necessary, some tanks may be emptied first and remain empty during completion of the exchange of other tanks, and then refilled. Yield should preferably remain less than 2 degrees in all steps. And execution may be halted at any time for a shorter or longer period. Safety considerations for the sequential method. Related to weather. Rough sea, bottom slamming in the fore-vessel, causing structural damage. This is dependent on the draft forward, and the vessel heading. If slamming is experienced during emptying of some of the tanks, it is possible to stop/reduce this by temporarily altering the vessel's heading or reducing the speed. Sloshing in tanks, causing deflection/damage to internal tank structure. Strong wind, depends upon the wind direction. If the ballast water exchange involves steps which cause that the vessel cannot keep upright condition all the time or reduced GM, side wind may contribute to heel/roll. Static heel should be maximum 2 degrees, preferably. Low temperatures in which icing in the ballast tank air pipes may occur. Clogging, ice plugs or malfunctioning of air vent heads may lead to structural damage to tanks. Crew safety, if ballast water exchange requires manual deck operations. Related to internal loads. Exceeding permissible maximum allowable limits with respect to longitudinal strength, shear force and bending and torsional moment. This could cause damage even in good weather conditions, and the stresses increases with increasing waves. Loss of stability, as emptying of ballast tanks will result in additional free surface moments and reduced GM/increased BCG, there should always be included a sufficient safety margin in the initial condition. The combination of full ballast holds and empty topside and/or hopper side tanks may induce dynamic loads which could exceed the capability of the sloped bulkhead structures and transverse ring web structures. Related to the vessel's operation. Operational limits in the approved trim and stability booklet shall be observed. Loss of visibility, according to SOLAS Chapter 5 Regulation 22.4, under certain conditions the line of sight requirements are suspended for the time of ballast exchange, provided that 1. The master has determined that it is safe to do so and takes into consideration any increased blind sectors or reduced horizontal fields of vision resulting from the operation to ensure that a proper lookout is maintained at all times. 2. The operation is conducted in accordance with the ship's ballast water management plan, taking into account the recommendations on ballast water exchange adopted by the organization, and the commencement and termination of the operation are recorded in the ship's record of navigational activities pursuant to Regulation Ballast 2009-5/28. Less propeller immersion. If the draft is reduced aft, the propeller may not be sufficiently submerged. Less rudder immersion. By reducing the draft aft, the rudder will also become less immersed, which may reduce the maneuvering capabilities some. Heel during exchange. If unsymmetrical ballast tanks are exchanged in the same step, the vessel's master should carefully monitor the heel during all steps and take necessary actions to reduce the heel as far as practicable. Related to the vessel's pump and piping system. System failure. Failure of the system in open sea may have larger consequences than in harbor. Increased use of the ballast system for ballast water exchange may result in earlier wear out of components than normal, vents, valves, pumps, gauges, etc. It is therefore important to pay extra attention to the maintenance of the different components. Over/under pressure of tanks, leading to structural damage. During filling/emptying of each of the tanks, one should avoid overpumping through air pipes when tanks are being filled, unless it has been verified that the tank design pressure is not exceeded during such operations and corresponding filling procedures are adhered to. It should also be checked that the venting system is functioning properly. Minimizing uptake or transfer of harmful aquatic organisms, pathogens, and sediments. Wherever possible, ballast water should be taken outside of port waters and as far from the coast as practicable. Consideration should also be given to the use of dockside water supplies, water not taken directly from the harbor, such as fresh water, potable water, etc., as source for ballast water. When loading ballast water, every effort should be made to avoid the uptake of potentially harmful aquatic organisms, pathogens, and sediments that may contain such organisms. The uptake of ballast water should be minimized or, where practicable, avoided in areas and situations such as 1. Areas identified by the port state in connection with warnings provided by ports concerning ballast uptake and any other port contingency arrangements in the event of emergency situations. 2. In darkness when organisms may rise up in the water column. 3. In very shallow water. 4. Where propellers may stir up sediment. 5. Areas with current large phytoplankton blooms, algal blooms such as red tides. 6. Nearby sewage outfalls. 7. Where a tidal stream is known to be more turbid. 8. Where tidal flushing is known to be poorer. 9. In areas close to aquaculture. 10. Where dredging is or recently has been carried out. If it is necessary to take on and discharge ballast water in the same location, care should be taken to avoid unnecessary discharge of ballast water that has been taken up in another location.